Hello, my dear students. How are you all? I am fine. I am Khandekar Fazle Rabbi, lecturer, Department of Chemistry, Milestone College, Uttara. During this pandemic situation, welcome you all to our online chemistry class. My dear students, today we discuss about some important topics from chemistry second paper, chapter 1, environmental chemistry. My dear students, now we discuss about composition of atmosphere. The air layer that covers the earth is called atmosphere. About 10,000 kilometers depth of the air layer made a living environment for a lively earth about 30 to 35 crore years ago. However, about 97% of atmosphere exists within 30 km from the Earth's surface. Atmosphere lies around the Earth's surface due to the force of gravitation and rotates with the Earth. But air cannot rotate with equal velocity with the earth, slightly slowly than the earth. As the moon has no force of gravitation, it has no atmosphere around like the earth. Now, what are the compositions of atmosphere? Atmosphere is a homogeneous mixture of few gases. Among them are first one, oxygen. Oxygen gas is the vital for respiration of the animal kingdom and plants. Second one, essential nitrogen gas for controlling the burning process. These two gases constitute about 99% of the total volume of the atmosphere. The third important constituent of atmosphere is carbon dioxide. Carbon dioxide gas is used for production of carbohydrate by the photosynthesis process by the plants. Besides these, there are some inert gases and water vapor. From the Earth's surface, as the height increases, the density of the atmosphere decreases significantly. For this reason, the atmospheric pressure at the ocean level is 1 atmosphere, which becomes 3 into 10 to the power minus 7 atmosphere above 100 km from the ocean level. The total mass of the atmosphere is 5 into 10 to the power 15 ton, which is about 1 part of a million of total mass of the earth. Usually, the density of the atmosphere is expressed in parts per million or parts per billion or parts per trillion. The different gases, water vapor, organic, inorganic particles are called collectively aerosol. Aerosol contains dust particles, salt particles, pollen, coal dust, smokes, ash, volcanoes, etc. These particles of the air absorb heat from the sun rays and warm the air. By the support of these particles, water vapor condenses and causes rain. On the other hand, the floating particles reflect the solar radiation, and as a result, beautiful colors are seen at the sunrise and sunset. The blue colors of the sky is created by the light radiation and reflection of light. My dear students, now we discuss about importance of atmosphere. Atmosphere consists of four layers which have definite breadth, composition and functions. The role of atmosphere is like first one, respiration. Atmosphere is of prime importance for us to live on with respiration. Without air we cannot live. Second one is weather or climate change, existence of life. In the troposphere, change of temperature and air flow take places. For this, cloud, rain, fog, dew, snow, etc. are resulted, that is, weather changes. So, in one word, it can be said, if there were no atmosphere, there would be no weather or region change, no rain, and without rain, there will be no green forest, no crop fields. If there were no rain, there would be no existence of life on the earth. Like the moon, the earth would be a barren desert. Third one is transference of radio wave. Atmosphere is a medium through which sound wave moves. The radio wave sent from the Earth's surface comes back to the Earth from the ionosphere due to obstacle from this layer. Fourth one is safety from UV radiation. Most of the ozone exists in the atmosphere layer. This ozone layer absorbs the harmful UV radiation coming from the sun. As the UV radiation cannot come to the earth, we are safe from the harmful effect of the UV radiation causing skin cancer. And the last one is safeguard. Atmosphere acts as a safeguard for the earth because meteor coming from the great void is destroyed in exosphere of atmosphere. For this, no life loss or damage of the environment occurs. My dear students, now we discuss about effect of temperature, pressure and density of air. First one, origin of cyclone and tidal bore. Due to the difference in structure or layers of atmosphere, different regional areas have difference in density of air and temperature. Regional climate is often described as the average weather in a place over more than 30 years. A region's climate is sometimes sunny, windy, dry, or humid. In different seasons, in different areas, wind flow and its speed, humidity of the air is different, as a result of which rain, cyclone, tidal bore, even natural calamity occurs. Let us examine the difference of temperature, pressure, density of air which causes cyclone and tidal bore. First one, difference in temperature and pressure. The intensity of heat from the sun ray is different in different areas of the earth depending on the latitudes. Sun rays fall on vertically in the equator and they fall on the poles obliquely. As a result, temperature is maximum in the equator, minimum in the north and south pole, extreme cold. On the other hand, if we go upwards from the sea level, both the density and temperature of air reduce. Generally, temperature reduces up to 6 degrees centigrade per 1000-meter height. For this reason, at different height of two places in the same latitude, different climates are seen. For example, Dinajpur and Shillong, being situated on the same latitude, have different temperature and rainfall. Shillong on the higher height has lower temperature and plenty of rain. The force or weight of the air on unit area is called atmospheric pressure. In tropical region, sun rays fall on vertically. So temperature is maximum, which increases the volume of the air. As a result, pressure of the air reduces, that is, low pressure cycle is created. On the other hand, in the north and south pole, as the temperature is lower, cold and heavy air flows downwards. As a result, high pressure cycle is created here. Second one is water vapor. There is a significant effect of water vapor on the climate of a place. If water vapor flows over an area and if it is observed there is sufficient rainfall in that place. For example, in Bangladesh, the monsoon year carrying plenty water vapor in rainy season causes heavy rainfall. In winter, the dry air flow causes no rain in the winter season. Third one is air current. Due to difference of sun heat and atmospheric pressure, cold and heavy air flows towards low pressure region from higher pressure region. Due to difference of pressure, the direction of air current and intensity become different. If abnormally low pressure in the air is created due to local or regional or global perspective, then all of a sudden wind flows towards the center of the low pressure with abnormal high speed. This sudden and irregular wind flow is known as cyclones, hurricanes, tornadoes, etc. In India and Bangladesh, this is known as cyclone. In Atlantic region, hurricane are in the forest typhoon. If in area the air becomes too hot and goes up, then low pressure is created. Then cold and heavy air of high pressure region of surrounding areas rushes towards the center of low pressure with high speed. The incoming air on becoming hot by entering in the low pressure current goes upward with circulation. Such circulating upward gusts of wind is called cyclone. A cyclone is defined as an atmospheric system characterized by rapid inward circulation of air masses about a low pressure center, usually accompanied center by stormy, often destructive weather. Cyclones begin in tropical regions such as Pacific Islands, North Australia, and other areas. Due to rotation of the earth, this cyclone has clockwise direction in the north and in the south the anti-clockwise direction. The atmospheric pressure in the low pressure center of cyclone is below 30 millimeter, that means 0.04 atmosphere, and the speed of the strong cyclone is 160 kilometer per hour, height 10 kilometer, diameter is up to 16,000 kilometer. My dear students, now we discuss about tropical cyclone. The cyclone created on the seashore area of tropical region is called tropical cyclone. Within 5 to 20 degree latitude from the equator, this cyclone is seen. A tropical cyclone is rapidly rotating storm system characterized by a low pressure center, strong winds, and a spiral arrangement of thunderstorms that produces heavy rain. They form over large bodies of warm water of the ocean surface. Cyclone activity peaks in late summer. Tropical cyclones are compact, circular storms, generally some 320 kilometer or 200 miles in diameter, whose winds swirl around a central region of low atmospheric pressure. The winds are driven by this low pressure core and by the rotation of the earth, which deflects the path of the wind through a phenomenon known as Coriolis force. As a result, tropical cyclones rotate in a counterclockwise direction in the north hemisphere and in the clockwise or anticyclonic direction in the southern hemisphere. The characteristic feature of the tropical cyclone is the eye, which is created by circular rotation by the clouds originated from condensation of water vapor. Tropical cyclones are known as vapors names in different parts of the world. In the North Atlantic Ocean and the eastern North Pacific, they are called hurricanes, and in the western North Pacific around Philippines, Japan, and China, the storms are called typhoons. My dear students, now we discuss about what is the difference between cyclone, hurricane, and typhoon. Tropical cyclones are known in different countries as cyclone or hurricanes or typhoon. There are storms caused by temperature increases or fall of pressure of the air, causing low depression. It can all sound confusing, but the location in the longitude is important. That is, locations where the storms occur. If a tropical cyclone occurs somewhat between 140° west and western coast of United States, we call it hurricane. Eastern Pacific and Atlantic. If the cyclone occurs between 140 to 180°, then it is called Central Pacific hurricane. Cyclone occurring in the west of 180° is called typhoon. Cyclone occurs in South Pacific and Indian. My dear students, gases obeys some rules due to their physical state and characteristics properties. This change of volume with change of pressure, temperature and number of moles follows some general observations from experiments. These generalizations resulting the volume, temperature and pressure of gases are called gas laws. Some of them are Boyle's law, Charles' law, Avogadro's law, Gay-Lussac's law. In addition to the above laws, there are also some laws of gas mixing. First one is Dalton's partial pressure law, and the second one is Graham's diffusion law. My dear students, now we discuss about Boyle's law. What is Boyle's law? At constant temperature, the volume of a definite mass of a given gas is inversely proportional to the pressure applied to that gas. If at constant temperature, temperature T, the volume of a definite mass of a given gas is V, and the pressure applied to that gas is P, then according to Boyle's law, we can write V is proportional to 1 by P, where T constant, or V equal to K by P, K equal to proportionality constant Then we can write PV equal to K. Equation 1. If the pressure of the gas of the gas periodically changes to P1, P2, P3 dot 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 Pn, and at that condition the volume is changes to V1, V2, V3 dot dot Vn. Then we can write according to equation number 1, according to equation number 1, that is P1 V1 equal to P2 V2 equal to P3 V3 equal to dot 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 Pn Vn equal to K. Therefore, we can say that at constant temperature the product at constant temperature the product of pressure and volume of a definite mass of a gas is constant. This is Boyle's law. My dear students, now explanation of Boyle's law through graphical representation. My dear students, at constant temperature, by applying different pressure on a definite mass of a gas, we get different volume of that gas. If we plot the value of P and V on graph paper in 3 different ways, like P versus V, we get a hyperbolic curve. That means this is P versus V curve. And if we plot volume versus pressure inverse 1, a straight line curve passing through the origin obtained when volume V of the gas is plotted against pressure inverse 1 at any constant temperature. And my dear students, A straight line parallel to pressure X is obtained when PV of the gas is plotted against P at any constant temperature. My dear students, each of the curve or straight lines is called isotherm. My dear students, now we discuss about Charles' law. What is Charles' law? At constant pressure, the volume of a definite mass of a gas increases or decreases by 1 by 273 part of volume at 0 degree centigrade. For each degree Celsius increases or decreases in temperature. So, according to Charles' law, if at constant pressure the volume of a gas at 0 degree centigrade is V naught, and if we increase the temperature at T degree centigrade, then the volume is Vt, and because of the increase of temperature at T degree centigrade, the volume increases V naught T divided by 273 according to Charles' law. So, at T degree centigrade, the volume is Vt equal to V naught plus V naught T divided by 273. And my dear students, if we decrease the temperature at minus T degree centigrade, at minus T degree centigrade, the volume will be V minus T equal to V naught minus V naught T divided by 273. This is Charles' law. My dear students, again at T1 degree Celsius temperature, the volume of a gas equal to V1, and at T2 degree Celsius temperature, the volume of a gas equal to V2. Now, according to Charles' law, we can write V1 equal to V naught plus V naught T1 divided by 273, and V2 equal to V naught plus V naught T2 divided by 273, equation number 2. Now, equation number 1 divided by equation number 2, V1 divided by V2 equal to V naught plus V naught T1 divided by 273 divided by V naught plus V naught T2 divided by 273, or V1 divided by V2 equal to V naught 1 plus T1 divided by 273 and V naught 1 plus T2 divided by 273. My dear students, now V1 divided by V2 equal to 1 plus T1 by 273, 1 plus T2 divided by 273, and 273 plus T1 divided by 273, 273 plus T2 divided by 273. V1 by V2 equal to 273 plus T1 divided by 273 plus T2. My dear students, let 273 plus T equal to capital T. Here T equal to absolute temperature. Absolute temperature. So we can write here V1 by V2 equal to T1 by T2, or V1 divided by T1 equal to V2 divided by T2. Now my dear students, V by T equal to K. That means here V1 by T1 equal to V2 by T2. So we can write here V by T equal to K, K equal to constant, K constant, and V equal to KT, or V is proportional to T. So my dear students, we can say that at constant pressure, the volume of a definite mass of a gas is proportional to its absolute temperature. My dear students, now we discuss about absolute zero temperature. Okay, my dear students, we get according to Charles' law, we get Vt equal to V0 plus V0 T divided by 273. Dear students, if we decrease the temperature at minus 273 degrees centigrade, then the volume will be V minus 273 equal to V0 plus V0 into minus 273 divided by 273. That means V minus 273 equal to V0 minus V0 equal to 0. So my dear students, we can see that at minus 273 degrees centigrade temperature, the volume will be 0, and this is known as absolute zero temperature. So we can say that at constant pressure, the temperature, that is minus 273 degrees centigrade, at which a gas has no volume, theoretically is known as absolute zero temperature. My dear students, here we write the graph of volume versus temperature. This at 0 degree centigrade temperature, the volume is V0. If we increase the temperature, then the volume increases, and if we decrease the temperature, the volume decreases, and at minus 273 degrees centigrade, the volume, that's why minus 273 degrees Celsius is known as absolute zero temperature. This is possible only theoretically. My dear students, now we discuss about establish a new scale for measuring of temperature from Charles' law. My dear students, according to Charles' law, we get Vt equal to V naught plus V naught T divided by 273. At minus 273 degrees centigrade temperature, we get V minus 273 equal to V naught plus V naught into minus 273 divided by 273, and we get the value is 0. Hence, at minus 273 degrees Celsius temperature, the volume of gas is 0 theoretically. This temperature is called absolute zero temperature. Taking the absolute zero temperature, that means minus 273 degrees Celsius as 0, a new scale of temperature known as absolute scale of temperature has been established. My dear students, the temperature measures on this scale are known as absolute temperature. This scale is also known as Kelvin scale, as the honor of Lord Kelvin, who is the inventor of this scale. The relation between Celsius and Kelvin scale is as below. Minus 273 degrees Celsius equal to 0 Kelvin, or minus 273 plus 273 degrees Celsius equal to 0 plus 273 Kelvin, and we get 0 degrees Celsius equal to 273 Kelvin, and 0 plus T degrees Celsius equal to 273 plus T Kelvin, and we get T degrees Celsius equal to 273 plus T Kelvin. This is Kelvin scale, or T degree Celsius equal to capital T Kelvin. If we see the relation over here, here is a centigrade scale, and this one is Kelvin scale. When the value of the temperature is 100 degrees Celsius at centigrade scale, then the value of Kelvin scale is minus 373 Kelvin. When the value of centigrade scale is 0 degrees Celsius, then the value will be in Kelvin scale 273, and when minus 273 degrees Celsius in centigrade scale, then the value in Kelvin scale is 0 Kelvin. My dear students, now we discuss about combination of Boyle's and Charles' law. My dear students, according to Boyle's law, we get V is proportional to 1 by P, where T constant. This is equation number 1, and according to Charles' law, we get V is proportional to T, P is constant. My dear students, from equation number 1 and 2, we get V is proportional to 1 by P into T, or V equal to KT by P. Here K equal to constant. Okay, now PV by T equal to K. This is the combination of Boyle's and Charles' law. If temperature is T1, T2, T3, Tn, then pressure P1, P2, P3, Pn respectively, and volume V1, V2, V3 and Vn, then we can write according to question number 3, P1 V1 divided by T1 equal to P2 V2 divided by T2 equal to P3 V3 divided by T3 equal to Pn Vn by Tn equal to K. This is the combination of Boyle's and Charles' law.